Hello everyone, welcome. And today I will be verifying the given solution to a differential equation. So how do you verify? To verify, first you need to identify the differential equation and also identify the proposed solution, find the derivatives of the proposed solution, substitution to the differential equation, and then simplify and check for equality. So let's get to the example. For the first one, it's an example. So here we have only first order differential equation. That means we have to have only the first derivative. As we can see, this is the differential equation and this is the proposed solution. We have two proposed solutions. So let's do the first one first. So y prime of the first given solution is negative 2 times 5e to the negative 2x. Okay? And this will become negative 10 times e to the negative 2x. Okay, just take the derivative of 5 times e to the negative 2x. So we just substitute this, which is just y prime, to this. So negative 10 times e to the negative 2x plus 2 times y. Y is just this one. 5 times e to the negative 2x. 2 times 5e to the negative 2x equals to 0. So does it equals to 0? Let's find out. So negative 10e to the negative 2x plus 2 times 5, 10e to the negative 2x. So this does indeed equals to 0. So this is a solution to this differential equation. So this is a solution. So let's just check mark it. And we have y2, which is e to 2x. So let's find the first derivative. So y prime is just 2 times e to the 2x. So we have just substituting this to here and this to here. So we have 2 times e to the 2x plus 2 times y2, which is e to the x, so times e to the 2x. Well, as you can see, does this equals to 0? No, right? So this does not equal 0 because it equals to 4 times e to the 2x, which is not equals to 0. So this is not a solution to this given differential equation. Okay, next we have y double prime minus 9y equals 0. So this is the differential equation, and this is the proposed solution. So as you can see here, the highest derivative is y double prime, so we just need to take y prime and y double prime. And we have, so y equals to e to the x. Let's check if it is a solution to this. So y prime is 3 times e to the 3x. Y double prime is 9 times e to the 3x. Okay, so substituting this to here, y double prime to the y double prime in the differential equation, we have 9 times e to the 3x minus 9 times y. This is y. So 9 times e to the 3x. Does it equals to 0? Yes, because 9 times e to the 3x minus 9 times e to the 3x is 0. So this is a solution to the differential equation. So let's check this one. if it's a solution. So y prime is, what's the derivative of cosine? The derivative of cosine is negative sine. And remember that if we have a composite function, oh yeah, I have to say this earlier. So if we have f of g of x prime, the derivative is just f prime of g of x and times g prime of x. Okay, so the derivative of cosine is just negative sine of 3x, and then we have times the derivative of the inside, which is just 3. Okay, so we have negative 3 sine of 3x. Okay, and we need to take another derivative, so y double prime is equal to negative 9, the derivative of sine x, derivative of sine is just cosine x, so cosine of 3x. Okay, so substituting this to the difference equation, we have negative 9 cosine of 3x minus 9, okay, minus 9 times y. What's our y is cosine of 3x, cosine of 3x, okay, and does it equals to 0? No, because we have negative 9 cosine 3x minus 9 cosine 3x is just negative 18 cosine of 3x, so it does not equal to 0. So this is not a solution to this differential equation. Wait, let me check if it's correct. So we have y prime equals to negative sine, 3, negative 3, and you have take the derivative, so it becomes 3 times 3, 9, and derivative of sine, which is cosine, and negative 9, negative, yep, you just substitute this one, so negative 9 minus y, this is y, so it's, yeah, it's correct, so this is not a solution. Okay, number 3, so we have this y prime minus xy equals to 0. This is the difference equation, and this is the proposed solution. So the highest derivative is just y prime, so you just have to have the first derivative. So we have y prime of 1 sub 1 is equals to c. C is an arbitrary constant, okay? So we have c times, well, x, the derivative of x squared over 2 is just 2x over 2, okay, times e to the x squared over 2, okay, and this simplifies to c times x e to the x squared over 2, and substituting this for the differential equation, we have c, okay, x e to the x squared over 2 minus, wait, sorry, this is x squared over 2, and minus x times y, x times c e to the x squared over 2, and as we can see here, cx e to the x squared over 2 minus cx e to the x squared over 2, this does equals to 0. And that means this is a solution to this differential equation. So this is a solution. And let's check this second proposed solution. So we have y prime is equals to, well, we just have 2x times e to the x squared. And substituting this to the differential equation, we have y prime, which is just 2x e to the x squared minus by x times y e to the x squared. Okay, and it's equals to, as we can see, when we minus them, we just have x e to the x squared. So this does not equal to 0. So this is not a solution to this differential equation. Next we have y double prime plus y equals 0. And this is the proposed solution. Y equals to sine x and y equals to cosine x. So the highest derivative is y double prime. So we just need to have the second derivative. So y double prime. Wait, let me just find y prime first. So y prime is equals to, so the derivative of sine x is just cosine x. And the second derivative of sine x, the derivative of cosine x is just negative sine x. Okay, and let us check if this is a solution. So we just substitute it. We have negative sine of x plus y, which is just our sine of x. And does it equal to 0? Yes, it does equal to 0. So this is a solution. Let's check the second proposed solution. So we have y prime equals to cosine x, and y prime is equals to the derivative of cosine x, which is just negative sine x, and y double prime must be negative cosine x. Okay, and so we check here, we have y prime double prime as this is this derivative, so negative cosine of x, substituting in the differential equation. So we have negative cosine of x plus our y cosine of x. Okay, and this does equal to 0. So this is a solution to this given the given solution is a solution to this differential equation. So let's move on. Okay, we have y prime equals to 3 times 3 times y to the 2 over 3, and we have the proposed solution y equals to x cubed and y equals to x plus 1 cubed. So the highest derivative here is just y prime, the first derivative, so we need to find just the first derivative, and y prime is 3x squared. Okay, and we just substitute it, so we have 3x squared equals to 3 times y to the power of 2 over 3. Well, y is our x cubed. We have 3 times x cubed to the power of 2 over 3. And here we can cancel 3 out here, and we have 3 times x squared. Well, this is the same, so this is a solution to this differential equation. And we have the second proposed solution. Let's take the derivative, and we have, so we'll use 3 times x plus 1 squared well, the derivative of the inside is just 1, so we can, this is times 1, it's just 3 times x plus 1 squared. Substituting this to the differential equation, we have 3x plus 1 squared is equals to 3 times y, x plus 1 cubed, and this is being to the power of 2 over 3. Okay, well, this can cancel out, which left us with 3 times x plus 1 squared. So this is the same, that means this is a solution. Okay, next we have x times y prime plus y equals to 0. With the proposed solution, y equals to c over x, where c is an arbitrary constant, and y2 equals to x. Okay, let's check. The highest derivative is y prime, so we just need to take until the first derivative. So c over x, c times 1 over x. Well, sorry. The derivative of 1 over x is just, as we can see here, c times the derivative with respect to x of 1 over x. And the derivative of 1 over x, we can make it as x to the negative 1, which is negative x to the negative 2. So we have negative 1 over x squared. And that means it's c times negative c times 1 over x squared. So that's our y prime. Okay. So substituting to the differential equation, we have x times y prime, which is negative c times 1 over x squared, plus y, c over x, thus that equals to 0. So x and 1 over x squared can cancel, reduce the power to 1. Negative c over x plus c over x, does that equals to 0? Yes, this equals to 0. So this is a solution. This guy is a solution to this differential equation. And next we have y equals to x, y prime is just 1. So substituting to the differential equation, we have x times c over x. Oh, sorry. X times 1. X times 1 from here. Y prime equals to 1. Plus y, with y is just our x. Does that equals to 0? No. This equals to 2x, which is not equals to 0. So this is not a solution. Okay, oops. Okay. We have y double prime minus 4y prime plus 4y equals to 0. We have proposed solution y1 equals to e to the 2x and y2 equals to x e to the 2x. Well, in here, this is a second order differential equation, so the highest derivative is y prime or y double prime, so we need to take the derivative until y double prime. So we have y prime of the first proposed solution, which is just 2 e to the 2x. Okay, y double prime is just 4 times e to the 2x. Okay, substituting to the differential equation, we have 4e to the 2x minus 4y prime, which is 4 times 2e to the 2x, then plus by 4y. This is our y. So 4e to the 2x. Well, we can times this. This becomes 8 e to the 2x plus 4 e to the 2x. Well, as you can see, when I add 4 e to the x plus 4 e to the x is 8 e to the x. This and 8 e to the x minus 8 e to the x. will be 0. This will be 0. So it does equal to 0. So this is a solution, okay, to the differential equation. And we have the second proposed solution, which is just we have y prime. It's just we need to do the product rule. So we have to leave the first term x and then take the derivative of the second, which is 2e to the 2x plus by the derivative of the first, which is 1 times itself, which is the not derivative, and which is e to the 2x. And this will come 2x e to the 2x plus e to the 2x. Okay, we need to have the second derivative, y double prime. Okay, so we need to have another product rule. So we have 2x times 2e to the 2x plus parentheses plus leave this one, so we have 2x, and then sorry, we take the derivative of the first, which is just 2 times e to the 2x, and then plus by e to the 2x. Okay, substituting this and this in the differential equation. Let's see what happened. So we have y double prime, which is just 2x times, well, let's make it like this. So we have 4x e to the 2x plus 2e to the 2x plus e to the x, which is 3 to the 2x. So yeah, plus 3e to the 2x, okay, minus 4 times y prime. Our y prime is 2x e to the 2x plus e to the 2x, okay, and then plus 4y, which is x e to the 2x. Okay, does that equals to 0? Okay, we need to simplify this more. We have 4x, wait, this is actually 4 times x e to the x. We can combine this and this. We have 8x e to the 2x, and then plus by 3e to the 2x minus 4 times 2x e to the 2x plus by e to the 2x. Wait, is this correct? 4 times y prime, yep, e to the 2x. And distribute 4, we have 8x e to the 2x plus 3e to the 2x minus 8x e to the 2x plus, well, we have minus 4e to the 2x. Does that equals to 0? And we see here this and this cancels out, but this and this does make it so 3e to the 2x minus 4e to the 2x is not equals to 0. This is equals to negative e to the 2x. So this is not a solution to the differential equation. Wait, let me check. So for x e to the 2x, yep, from here y double prime, we have yep, okay, this is valid. Okay, next we have y prime equals to x over y, and we have proposed solution, y1 equals to square root of x squared plus c, y2 equals to negative square root of x squared plus c. Okay, so and here we just have a first derivative. That means we have only need to take the first derivative. So the first derivative of this is just negative 1 over 2 square root of x squared plus c times our derivative of this side, which is just 2x. Okay, and with why this is like this, we have square root of derivative of respect to square root of x squared plus c. Well, this is just x squared plus c squared, right? We have 2 1 over, and taking the derivative with respect to x, we minus, this will become with 1 over 2, and this will become x squared plus c negative 1 over 2. So we have 1 over 2 square root of x squared plus c. Oh wait, sorry, my apologies, this is wrong. Okay, so it's 1 over 2 square of x squared plus c, and times by 2x. If we just take in the derivative of inside, 2x from here, we have 2x. So this one cancels out, leaving us with x over square root of x squared plus by c. And we have so we need to substitute this. We have to the differential equation y prime is just this. That means we have x over square root of x squared plus an arbitrary constant. Does it equals to x over y? And well, if we cancel this can cancel out, like so we have 1 over square root of x squared plus c equals to x over yx. Yeah, so it cancel out, and that means square root of x squared plus c is equals to our y. And here, well, that's true. So because our y here is the square root of x squared plus c, and y here square root of x plus c. So square root of x plus c is equals to square root of x plus x squared plus c. So this is a solution to this differential equation. And here y equals negative square root of x squared. So y prime is just negative, the same, yeah, but negative x over square root of x squared plus c. And we have, so that means from here we know that, yeah, the x cancels out, and we have negative, I mean, we have negative square root of x squared plus c is equals to y, where, well, this is correct because our y is negative square root of x squared plus c. So this is a solution also. Okay, wait, if we want to recheck this, well, we have y prime, which is a negative x over square root of x squared plus c is equal to x over y, and this cancels. That means we have negative square root of x squared plus c is equal to our y. So it does, it is correct. So that's a solution to this differential equation. Okay, final two. We have y prime plus y times cotangent x equals to 2 cosine of x. We have two given out solution, proposed solution. So this is just how we have the highest derivative is y prime, so we need to have just have to take the first derivative, so y prime equals to cosine of x. Okay, and we directly substitute it. We have cosine of x plus y, which is just sine x times cotangent of x is equals to 2 cosine of x. Well, is it true? Well, cotangent of x is just sine over cosine. Cosine of x plus sine of x cosine over sine. I'm sorry, it's just cosine over sine x. Okay? And sine x can cancel. Well, we have cosine of x equals to 2 cosine of x. Well, this is true. That means it's a solution to the differential equation. Okay, we have the second proposed solution. So we have y2 prime. Well, this is just cosecant of x, right? A derivative of respect to x of cosecant of x, because 1 over sine of x is just cosecant of x. And the derivative of cosecant of x is just negative cosecant of x times by our cotangent of x. Okay, this is y2 prime. So we can substitute it to here. We have y prime, which is negative cosecant of x times cotangent of x plus by y. Our y is just cosecant of x here. Cosecant of x. We have cosecant of x times cotangent of x. That is equals to 2 cosine of x. Well, this will cancel out because the values are the same. And there's a negative here. This is positive, so this equals to 0. So this does not equals to 2 cosine of x of 2x. I mean cosine of x. That means this is not a solution to this differential equation. Okay, next. So we have y double prime minus 2y prime plus 2y equals to e to the x cosine of x. Well, we have two proposed solution, and this is y prime. So we need to get until the second derivative. Y prime equals to, well, we have to use the product rule. We have e to the x negative sine of x times negative sine of x plus by our derivative of e to the x cosine of x. Okay, now y double prime is, okay, another product rule. We have e to the x negative cosine of x plus e to the x negative sine of x. Okay, just to be clear, this is the product rule of this. Wait. Yep. Oh, I can write this. Okay, this is the product rule of this derivative, and plus, okay, another product rule. We have e to the x e to the x, the derivative of cosine is negative sine of x, and plus by e to the x, the derivative of e to the x is e to the x times our cosine of x. And let's see if there's a like term. Well, negative cosine. Oh, as we can see here, this and this can cancel out. Can this cancel out? E to the x. This was a y double prime is equals to a negative e to the x sine of x minus by e to the x sine of x. We have 2 negative 2 e to the x, okay, sine of x. This is our y double prime. So substituting to the differential equation, we have y double prime negative 2ex sine of x minus 2y prime, or y prime is e to the x sine. Also, it's negative. Wait, sorry. So it's negative e to the x sine of x. Wait, this is 2 times actually. I'm sorry. Wait. Minus 2 times y prime negative e to the x sine of x plus by e to the x cosine of x, and plus 2y. Okay, we have plus 2 times y. What's our y? E to the x cosine of x. Does it equal to e to the x cosine of x? We distribute 2. We have, well, this and negative 2 times positive, so this is positive 2 e to the x, and this cancels, which leaves us with negative 2 e to the x cosine of x plus 2 e to the x cosine of x. Does that equals to e to the x cosine of x? No, this becomes 0. So this is not a solution to the differential equation. And let's try the other one, y2. And so y prime is, well, okay, we need to do, so let's also have y times the derivative with respect to x of our x e to the x sine of x. Okay, let pick this term and this term is together and this term is alone. So we have a half times the product rule, which is x e to the x. Well, this is correct. So x e to the x times the derivative of sine of x, which is cosine of x plus by, okay, the derivative of this. Okay, we have to have another product rule. So we have x, okay, e to the x, derivative of e to the x, plus by our derivative of x is just 1 times e to the x, okay, and then this is cosine, so this is sine, okay, sine of x, okay. Simplify this, we have a half x e to the x cosine of x plus sine, okay, x sine of x e to the x plus e to the x sine of x. Okay. Is there a term we can combine? I think there's no, so I have to check if this product rule is correct. And we have x e to the x times the derivative of sine x. We have the derivative of this one and times our sine x. Okay, so it's correct. Now we have to do the second derivative. Okay. X e to the x cosine of x. Let's do it in the next page. So we need to have derivative of x e to the x cosine of x. So derivative with respect to x of x e to the x cosine of x. Is it correct? Yep. It's just okay. So this term is together and this term is alone. We have x e to the x plus times our derivative of cosine, which is negative sine of x. Okay, and plus by our derivative of that. So the derivative of that is x e to the x plus 1 times e to the x, okay, times our cosine of x. And this equals to negative x e to the x sine of x plus x cosine of x e to the x plus e to the x cosine of x. Okay, next we have the derivative of this x sine of x e to the x. Okay, with respect to x sine of x e to the x, or x e to the x sine of x. Okay, we have the same idea, y prime. This is the first component as y prime a, y prime b, y prime algebra prime b, and so we have x e to the x, okay, as the derivative of sine of x is cosine of x, and then plus by our derivative inside is x e x plus 1 times e to the x. Okay, we have a sine times sine of x. Simplify this more, plus x sine of x e to the x plus e to the x sine of x. Okay, well, can we combine? No, we cannot. So move on to the next derivative, final derivative, so e to the x sine of x. So derivative respect to x of e to the x sine of x. Yep. Okay. This is just our product rule, so it's cosine of x plus by e to the x, the derivative of e to the x times sine of x. Okay, and this is so our y double prime of 2 must be half times our y double prime a plus y double prime b plus y double prime. This is our y double prime c, and half times y double prime a is is our y double prime? So negative x e to the x sine of x plus x cosine of x. Oh, okay. To make it a lot faster to write, I'm just gonna say tau is equal to cosine of x and alpha is equal to sine of x. Okay. Um, we have a half times our y double prime of a. So we have negative e x e to the x of sine of x, which is our alpha, plus by x cosine of x, x e to the x, our tau, okay, and plus e to the x times tau. Okay, next we have this one, y double prime b. So we have plus x e to the x of our cosine, which is tau, okay, and then plus x sine of x e to the x, x plus x e to the x sine of x, which is our alpha, and plus by e to the x sine of x alpha, which is alpha, and plus by y double prime c is just plus e to the x tau plus e to the x alpha. Okay, and we can simplify this e to negative x e to the x with alpha x e to the x alpha cancels out, and tau, there's no negative, so we can combine these. So y double prime 2 is a half times x e to the x tau, so 2x e to the x tau plus e to the x tau, we can combine with this one, so we have 2 e to the x tau and plus e to the x alpha plus 2 e to the x alpha. Okay, we can distribute a half. We have x e to the x cosine of x plus e to the x cosine of x plus e to the x sine of x. Okay, nice. We have this now, which is our y double prime 2. Okay, so our y double prime 2 is x e to the x e to the x cosine of x plus e to the x cosine of x plus e to the x sine of x. Okay. Substituting to the differential equation, we have x e to the x cosine of x. Oh, let's use the notation then, tau. We have x e to the x tau, okay, plus e to the x tau plus x e to the x tau plus e to the x tau plus by e to the x alpha, okay, and minus by 2 times y prime. Our y prime is this guy. So we have so the original one, so alpha x e to the x tau plus x e to the x alpha, okay, plus by e to the x alpha. Okay, that's our y prime. Then we have plus 2y, plus 2 times our y, which is a half e to the x e to the x alpha. This can cancel. We have plus a half. I mean plus by um x e to the x alpha. Okay, and let's see, is there any term that can be cancelled out? So x e to the x minus x e to the x tau. Okay, e to the x alpha minus e to the x alpha cancelled out. X e to the x alpha minus x e to the x alpha cancelled out. So we have e to the x tau. Well, e to the x tau is just cosine of e to the x cosine of x. Well, does it equals to e to the x cosine of x? Yes, cosine of x. So it's true. So this equation, this proposed solution is a solution to this differential equation. So this is a solution. Okay.